Today we are going to learn about debugging Python decorators like a pro. We will discover techniques to efficiently troubleshoot and resolve issues in decorator implementations, boosting your ability to maintain robust Python applications.
Welcome to our video on debugging Python decorators like a pro. In this session, we're going to explore the intricate world of Python decorators, focusing specifically on debugging them efficiently. Decorators are a powerful feature in Python, allowing you to modify the behavior of a function or class. However, they can be tricky to debug due to their complex nature. Today, we'll dive deep into various techniques and tools that will help you troubleshoot and resolve issues in decorator implementations, ultimately aiding you in maintaining robust Python applications. Let's get started with the basics and gradually move to advanced debugging techniques.
Let's begin by understanding some common pitfalls when using Python decorators. A frequent issue is misunderstanding how a decorator modifies a function's behavior, which can lead to unintended outcomes. It's crucial to remember that decorators wrap functions, meaning they can alter inputs, outputs, and even the function's logic. Another pitfall is mishandling function signatures, especially when decorators need to pass through arguments correctly. This can be avoided by using tools such as functools.wraps, which we will discuss later. Additionally, state retention is another challenge. Decorators might inadvertently retain state across different function calls, leading to unpredictable behavior. Global variables can exacerbate this issue, as they introduce side effects that are difficult to trace. By being aware of these pitfalls, you can take proactive steps to avoid them and ensure your decorators function as intended. A powerful tool in debugging decorators is the functools.wraps function. One of the most common issues with decorators is that they can obscure the original function's metadata, such as its name and docstring. This can make debugging particularly challenging, as it becomes difficult to trace the function's original purpose and usage. Functools.wraps is designed to counteract this by copying the metadata from the original function to the decorator, preserving the function's identity. This not only aids in debugging but also enhances code readability, making it easier for others to understand your code. By using functools.wraps, you also minimize the risk of signature mismatch errors, which can occur when the decorator inadvertently alters the function's signature. Implementing functools.wraps is straightforward. Simply decorate your inner function with that functools.wraps followed by the original function. This small step can save you significant time and effort when debugging decorators. Nested decorators add another layer of complexity to debugging. When multiple decorators wrap a function, tracking the execution flow can become challenging. One effective strategy is to use print statements strategically to log information at different stages of the decorator chain. This allows you to see the order in which decorators are applied and identify where things might be going wrong. Another useful technique is to isolate each decorator and test them individually. By doing so, you can pinpoint which decorator is causing the issue. Once identified, you can focus your debugging efforts on that specific decorator, rather than tackling the entire decorator chain at once. This methodical approach helps you break down the problem into manageable parts, making it easier to resolve issues in nested decorators.
While print statements can be helpful for quick debugging, utilizing Python's logging module offers a more robust solution. Logging provides several advantages, such as the ability to configure different log levels, debug, info, warning, error, critical, which allows you to capture varying degrees of detail about the program's execution. Setting up logging is relatively straightforward. Import the logging module, configure the basic settings, and replace print statements with logging calls. This approach not only captures detailed execution data but also creates a permanent record that can be analyzed later. By reviewing the logs, you can identify patterns or anomalies that may indicate issues with your decorators. With logging, you gain deeper insights into your program's behavior, making it easier to pinpoint and resolve problems. Python offers a powerful built-in module called inspect, which provides several utilities for introspecting live objects. This can be incredibly helpful when debugging decorators. With the inspect module, you can access function signatures, retrieve the source code of functions, and examine various function attributes. This allows you to see how a decorator affects the function it wraps. For instance, you can use inspect.signature to get a detailed view of a function's parameters, helping you ensure that decorators are handling arguments correctly. Similarly, inspect.getSource allows you to view the source code of a function, which can be useful when trying to understand the effects of a decorator on the function's logic. By leveraging these inspection tools, you gain greater visibility into your code, aiding in the debugging process.
Exception handling is a critical aspect of debugging decorators. Without proper exception handling, errors can propagate and cause unexpected behavior in your applications. To handle exceptions effectively within decorators, it's essential to catch exceptions and log them for analysis. A common approach is to use try-except blocks within the decorator to catch any exceptions that occur during the execution of the wrapped function. By logging these errors, you create a record that can be reviewed to understand what went wrong. Additionally, consider making your decorators fault-tolerant, so they can gracefully handle exceptions and continue executing without disrupting the overall application. This proactive approach ensures that your decorators are robust and reliable, minimizing the risk of errors causing significant issues. In real-world applications, decorators can encounter a variety of issues that require debugging. One common scenario is performance bottlenecks, where decorators inadvertently slow down function execution. To address this, use profiling tools to identify slow spots and optimize the decorator's logic. Another scenario involves handling unexpected input, which can cause decorators to fail. Implementing robust input validation within decorators can prevent this. Compatibility issues can also arise when decorators are used across different Python versions or libraries. Ensuring that your decorators are compatible with various environments is crucial for scalability. By considering these real-world scenarios, you can develop strategies to effectively debug decorators and maintain high-performing, reliable applications. For those looking to take their debugging skills to the next level, advanced techniques can provide deeper insights into decorator-related issues. One approach is to use debuggers that support stepping through decorator code, allowing you to observe its behavior at runtime. Dynamic introspection can also be employed to analyze the state of decorators during execution. Additionally, examining stack traces can help identify where in the decorator chain an error occurs. Creating custom debugging utilities tailored to your specific needs can further streamline the debugging process. Finally, integrating decorators with testing frameworks allows for automated testing, ensuring that decorators function correctly in various scenarios. By mastering these advanced techniques, you can tackle even the most challenging decorator-related issues with confidence.
As we wrap up this video on debugging Python decorators like a pro, let's recap the key techniques we've covered. We've explored common pitfalls, the importance of using functools.wraps, strategies for debugging nested decorators, and the benefits of logging over print statements. We've also delved into Python's inspection tools, exception handling, and real-world debugging scenarios. By mastering these skills, you can efficiently troubleshoot and resolve issues in decorator implementations, enhancing the robustness of your Python applications. I encourage you to practice and experiment with these techniques, and explore additional resources to deepen your understanding. Finally, don't hesitate to engage with the community for support and knowledge sharing. Thank you for joining us, and happy debugging.